Hi, everyone, and welcome to the Genetics Podcast. I'm here today with Dr. Anna Lewis, who's a researcher at Harvard focused on ethics as it relates to the return of predictive genetic test results and gene editing. We're going to cover a lot in this episode, including those two. If you've listened to the podcast before, you'll know that I love these kinds of ethics discussions because technology developments simply don't happen in a vacuum. And in particular today, we're facing some very challenging ethical dilemmas. There are many, many more people getting genetically tested through healthcare system, through research biobanks. Gene editing is now a reality. All of these technological changes are starting to come together to produce some really profound ethical questions. So Anna, welcome to the podcast, and thanks so much for taking the time to join us.
Thank you for having me.
So you did your PhD in computational biology. You worked as a computational biologist and then a product manager for some time, and now you're in ethics research. Something that really jumped out to me from your bio is that I think you've said before that, quote, and I'll quote you, day-to-day confrontation with ethical issues led you to wanting to pursue ethics full-time. I'd love to start there. What were you doing when you started thinking about going to ethics research full-time? Was there a single event that made you think you want to do this, or what was it like?
Well, I'll name two events. One was when an academic collaborator of mine, when I was in industry, sort of bounced up to me and said, Anna, I've worked out how to put a score on a genome. I was like, oh, really? There's all sorts of ways that things could go from here with that kind of idea. And the other one was the first time I wrote a consent form for a genetics research study. And here in the States, you have to include this very standard paragraph of text, which explains that although there's legislation that protects individuals from being discriminated against in the context of health insurance, it does not cover other forms of insurance, including life insurance. And it's just like, hey, this is a thing. No further information.
FYI. Yeah.
And that just felt really bad to be putting that in front of individuals with no further information, and just, it seemed completely non-acceptable. And so I think I've got interested in, this world is called the ELSI world. It stands for the ethical, legal, and social implications of genomics. Genomics is the original ELSI. There's now just starting to be ELSI of these other new technological areas like MLII, for example. And I view this field as a sort of contextual wraparound to the technology. It's lots of pieces that aren't right at the core. It's about how that technology is going to impact individuals and society.
Absolutely. What have been the biggest changes since the very first time somebody said to you, hey, I think I could put a score on a genome? What score was that? Do you remember? And what's changed since then?
Well, that was focused on analysis of rare variants and this idea of genomic burden, which hasn't really taken off yet. I still think that might take off. But of course, the big thing which has hit center stage are polygenic risk scores, which are based around common variants. And an implication of it being the study of common variants is that it's accessible just via this much cheaper technology of genotype chips. As you know, and I'm sure you've discussed with many other people on this podcast, this is now a huge research endeavor, the publication of new polygenic risk scores. And the underlying technology for creating them is basically the same for any trait. So if you've got yourself a phenotype and you've got yourself some genotype information, it's very, very easy to calculate one of these polygenic risk scores. It's not to say it's going to be a good such score, and we can talk about that. But then you've got this number that you can attach to an individual. And in a seminal paper from 2018, some researchers here at Harvard were like, the time to think about clinical application is now, because we can start to detect effects at the same sort of effect size as some of the monogenic variation that we return results for. And I've been involved in a couple of big studies which are returning results, polygenic risk score results to individuals. And there's all sorts of ELSI things which come up in that context.
Yeah. What are some of the big issues that have come up or that you all are thinking about? And in particular, I think it'd be interesting. I know in a couple of your papers, you specifically contrast the framework for monogenic risk scores, or monogenic risk. They're not really scores. They're kind of scores. They're often 0 or 1, but with polygenic risk scores that really run a spectrum from the extreme end where it's like monogenic to the other extreme end where it's protective. I'd love to hear what some of the big hitting issues that you think about a lot are.
Yeah. So a polygenic risk score is just a number. It's uninterpretable as it is. And so you have to put that in context somehow for the person receiving the information. And the simplest thing you can do is return a percentile. So you can say you are at the 98th percentile for coronary artery disease. That sounds like a really high number. Maybe you should be concerned about it. But the problem with returning information like that is you have no idea how predictive the underlying score is. It could be that you're at the 98th percentile, but that's only an increased risk of some small amount. So maybe you want to frame it in some other way. And the next easiest thing to do is to frame it as a relative risk. So you might say, you're at 3 times the risk compared to the general population, say. But notoriously, there are all sorts of issues with returning relative risk to individuals. It's very easy for risk to end up exaggerated if you use that kind of language. And then sort of better yet might be incorporating into absolute risk models where you could say, combining your polygenic risk score with these other risk factors, your 10-year risk of a heart attack is X%. So you've got to think about these different ways that you could integrate polygenic risk scores. And you've also got to, there are also some decisions about, are you just going to return right at the high end of the polygenic risk score range? Or are you going to make it a continuous number that you include? So there's all sorts of things which are questions about how do you actually return these to individuals? And the other really big one with polygenic risk scores is the impact of the study population and the validation population. So no matter which way you cut individuals up into categories, whether you're somehow forming some notion of continental genetic ancestry, whether you're looking at self-identified race and or ethnicity, what you're going to find is when you can then take your polygenic risk score and look at how it performs in one of these populations, you're going to see very different performance depending on these different ways that you cut up. So most infamously, the scores perform much worse in individuals of African ancestry than individuals of European ancestry. These are all population level summary statistics, I should say. And that's a problem when we think about clinical application, because the quality of the data that goes back to those with African ancestry is just worse. And it's not clear how to deal with that. You could take the line that, it's worse, so we're just not going to return it at all. Myriad have a score for breast cancer, a polygenic risk score for breast cancer that's currently only available to individuals or to women of European or Ashkenazi Jewish ancestry. They're working on updating that, but that's still the current status right now. So that's one option you can take. Another option you can take is attempt to show that it performs less well on the report somehow. That also has issues. Yeah, and then a big issue, which I'm sure you've seen as well, I know you think about, is it's just very, very hard to convey any kind of probabilistic information to individuals. There are all sorts of gotchas, and it's not just people on the street. Physicians also struggle even with percentiles often, which is kind of shocking.
Absolutely, yeah, it is. And people aren't trained in genetics necessarily, right? The field has changed so quickly that medical school may not have had these concepts for most people practicing. Just, even if 10 years ago you're in medical school, a lot has changed.
Yeah, that's definitely true. And I feel like a lot of scholarship ends up by concluding that we need massive amounts of new education. You might say there's a flip side. Some people would argue, well, look, the more emphasis we put on this, the more exceptionalist we're being about genetic information. And that's not a good thing. That's a very active debate, the extent to which we should treat genetic information very separately and put higher bars to its incorporation into clinical practice.
Yeah, I'd love to actually unpick that debate, because that is it's an important one. What is the framing in your mind there, and where is genetics non-exceptional and it should be treated just like every other experimental thing in the healthcare system, and where is it exceptional?
Well, there was a lovely article out last year, I think, arguing for genetic contextualism, which I think is appropriate. Typically, the debate has been coming from the LC world, actually, about genetics being exceptional for the sort of standard reasons, implications for family members, the fact it doesn't change, much closer ties to identity, and these sorts of things. And on the flip side, there have been not so many voices who want to emphasize its continuity with other information. There's lots of other information which is also forward-looking. Like a lot of clinical measurements that we get also can be used to predict your health status later in life. We can say probabilistically quite a lot about your family based not on your genetics, but on your phenotype and on your lifestyle, just because those are also correlated through family members. But then, there might be specific cases in which it is more appropriate to be more exceptionalist about genetic information. Anything where there's a chance, for example, that the sort of genetic genealogy pieces are going to come into play, or forensics are going to come into play. Genetics, I think, is still real standout in those areas.
Yeah, I'd love to maybe dive into a specific example and learn how you break it down from an ethics perspective. So if we took polygenic score for coronary artery disease as an example, and we were thinking through from an ethics framework, how should genetic test results be returned to an individual, for example? And we can be more specific in order to break it down. But let's suppose somebody was enrolled in a research biobank, very general. So they enrolled to donate their genetic data to be used in research, not specifically for coronary artery disease, but a polygenic risk score is discovered that says we can find a small fraction of people, 1 or 2%, that we know based on their genetics and a few other risk factors, they're at really high risk. How do you think about whether the people running that biobank should get in touch with the 1% of people in the biobank that carry that risk or not? How would you frame that question from an ethics perspective?
Well, I'd say, first of all, a lot of this is about how you set up the biobank in the first place. So the lion's share of the scholarship is on, okay, you're about to set up a biobank. How should you think about this? It's not about you've got this biobank, it's already set up, and now you're having to backthink and untie a lot of messes made. But if we take the prospective case, so you're setting up a biobank and you're thinking about basically what you owe your participants.
Yeah, I think that's a great way to put it.
Yeah. So there's the first thing to say is this depends radically on which country you're in, what the legal framework might actually be. The legal policies and regulations that are in place are surprisingly strong, I think, in terms of saying that if you come across clinically actionable results, then you should return them. What we see, though, is with genetic data is a real mess between this idea of incidental findings and secondary findings. And these are separated clearly in the literature, but in my opinion, not clearly in practice. So incidental findings are the things that some researcher looking at that biobank data stumbles upon. They weren't actively looking for them, but they stumble upon it. And you can easily imagine how this might be. Somebody opens like a genome browser and they're looking at BRCA and they see a really obvious pathogenic variant. Like that would count as clinically actionable and should be returned in sort of the framework I was laying out. So in that case, they ought to return that BRCA variant. But then again, they might have set themselves up not to do what's called the secondary findings, which is when you actively go and look for some set of conditions, some set of variants that are clinically actionable. So I think this is like a dodgy division because in practice, it's so easy to look for certain variants. Like if you're a variant that's very well annotated as pathogenic in some database, going and getting that piece of information is like a lookup function, right?
Yep. And it's often a routine part of analysis, right? Where you maybe exclude people from an analysis that you know have a disease-causing genetic variant.
Right. Absolutely. So I think our sort of LC framework for thinking about these things needs some updating. But it's because of the prospect of this kind of finding, whether you're going to look for it or stumble upon it, that these legal frameworks exist. And then there's also a whole lot of separate overlapping and mutually reinforcing ethical arguments for why you should return these findings. Those include the rights of participants, right to know, right to access, etc. They also include duties of the researchers, including duty of ancillary care, duty to warn, duty to rescue. And then there can be some just straightforward appeals to what we call beneficence. So like as a researcher, you can do good by pointing out to somebody, hey, to use the BRCA example, you've got this pathogenic BRCA variant. You should think about having much more screening than you're currently having. So that's kind of how the framework shapes up. I'll mention one other thing, and I think that you guys are part of this trend, which is for more research participant engagement with research, not just treating participants as sort of passive donators of data. They're sort of part of the process. That's another worldwide trend, which is leading to the importance of return of individual research results. So that's some of the context. What should you then do with that? Well, the most important thing is that when you set up your biobank, you should think it through carefully. You should think through what your protocol is going to be. That then, of course, has to get reflected in the informed consent document. You definitely need to budget to do this because it's not cheap. You need to sort of share your tools and processes to enable others to do a similar thing and bring down those cost barriers for research studies to do this sort of thing.
So now moving from a top 1% highly actionable or the BRCA case into the messy middle of things, how does it change, if at all, to say returning information about 10 polygenic scores covering BRCA to coronary artery disease to Alzheimer's, where I may be in the 50th percentile in one and the 95th in another and the second? How does that change? And also, how does the participant kind of choice factor into all of this? Because this is almost one of the most interesting parts of it to me, because I think there's one camp that argues basically the participant choice is paramount. And if I give the information and say, here's what I'm going to tell you if you agree, and here's exactly what it is and isn't, if you agree, you get the info. If you disagree, you don't. Or the other camp that says actually people, may not always be able to handle that truth. And even if I try to explain it, people may not understand, or I may not explain it well enough. So therefore, there's some things that we just shouldn't ask. I'm really interested when it gets into the messy middle part of this, how things change and how you think about it.
Sure. Well, let me carve that into two. And the second part will be models for consent. And in answer to the first part, that you could potentially return all these polygenic scores for a lot of different conditions, and you have to think about under what conditions to return. I'll mention experience with a big project over here in the US. It's called eMERGE 4. It's a big NIH-funded project. It's going to involve the return to about 25,000 Americans of about 10 polygenic risk scores. So we're still in the planning stages, still in year one of this project and end of year one. And it's exactly those questions which we've had to decide upon. And the thing that's really motivating the return of polygenic risk scores, and that's motivating return of results in research studies, is this idea of clinical actionability. So one approach that you can take that I think is sensible and that's been taken by eMERGE is you can say, well, how do we decide what's clinically actionable? And there, at least for the time being, genetics can look to how other risk information is incorporated into clinical decisions in certain phenotypes. So to take the example of colorectal cancer, there are pre-existing guidelines that say, if you have a strong family history defined in whatever way for colorectal cancer in your family, then your screening intensity goes up in such and such a way. So then what you can do is you can look at, well, what is the risk level associated with having a strong family history? Typically, that'll be some kind of relative risk information that you can get. And then you can say, okay, well, we'll set the same threshold for return of our polygenic risk score to that pre-existing guideline. So that's an approach you can take. And for a lot of conditions, there are such similar pre-existing guidelines. And of course, the conditions we're focused on are the ones for which some kind of preventative measures are possible. Otherwise, why would you focus on them? And if you're going to take that approach, then you're not necessarily going to return any information about the middle of the spectrum. You're just going to focus on the people who are above that clinical actionability threshold. This is not an easy choice, mind you. Lots of people might say, hey, I want to know if I
want it all.
Bring it on. It all. So here it might depend on the context. And in your biobank example, that'll depend sensitively on how you've set it up in the first place and what you have told participants you will return to them. If you have phrased that very strongly around clinical actionability, then you should probably think about it in a similar way to how I just outlined. If instead you phrased it like, we're going to give you all this cutting edge, cool stuff, which really isn't reliable at the moment, but you might be interested in looking in, and like massive, like buyer beware, not buyer beware, but like big pinch of salt needed.
Advisory, advisory that it may not be
right.
Totally polished. Yeah.
Even then, to now segue into the consent conversation, even if they've sort of said, yeah, give me everything, there are some things that could potentially have large impacts on people. So we have all sorts of frameworks for consent, like regular consent is distinguished from broad consent, which is where you're just like, hey, take my data and basically do anything. It's very open-ended. That type of consent is sort of increasingly sought by researchers. You can do granular consent, where you ask for participants' views or wishes for specific types of information. Like one typical thing would be like, what about something that's not treatable? So your Alzheimer's example, we tend to say it's actionable, but it's not really clinically actionable. It's actionable in that you could go and buy life insurance, or you could go make plans for your care later in life and that type of thing. But unfortunately, it remains the case that we don't have good treatments. The sort of reasoning behind something like granular consent is that these are questions on which reasonable people can sensibly differ, right? You might want to know your Alzheimer's risk, and I might not. And both of those are perfectly legitimate and understandable attitudes. And that's why it's important to ask about them. Another model for consent allows for updates of preferences. Like you might decide when you sign up for this biobank that you want everything. And then for whatever reason, you might decide, actually, no, you don't want to know everything. So having the ability to go back in and say, actually, no, I said yes, but I've changed my mind. It's not a straightforward process, this consent business. And I think one issue that we're having is that the answer to any sort of tricky question when it comes to research participants is be transparent, put it in the consent form. And then you've got consent forms which are pages and pages and pages and pages long. And do we think that participants read them all? Not so sure. And the cases in which people have studied, do people actually understand what's in the consent forms? The results do not look good. So you can solve some of these by always having a person in the loop, be it a counselor, a genetic counselor, or somebody else. All of this adds to the expense of doing genetic research. And I'll just mention one more thing and then I'll shut up. You mentioned some others who might have slightly contrarian views on these topics. And that line of thinking would say something like, if we put all the emphasis on consent, then we're inevitably going to end up with, that's not very compatible with an equity angle, because it's going to select for people who have a lot of time and a lot of mental energy to put towards thinking through these things. So there's some kind of trade-off there. And if we're talking about a situation where there really is potential benefit to participants, then you're going to have certain groups of people systematically losing out. So there's a lot of talk now, rightly so, about who gets recruited into research studies. We have big overrepresentation of educated white folk, basically. But there are lots of good reasons why other folk do not participate in research. It's not just that they haven't been asked to participate.
Yeah, absolutely. And I'd love to revisit that aspect of diversity and inclusion, because you mentioned it earlier with polygenic scores and how they don't work the same for everyone. And I think the numbers of people of European ancestry and genetic studies has more or less remained unchanged at 85% plus over the last 10 years. And it's a huge issue. What do you see, particularly in terms of getting these tests into clinical practice? What do you see as the solution? You talked a little bit about it earlier of it doesn't seem good to say no one gets it until it's equal for everyone, because then, even if it's doing something, it maybe is worth putting it out there. But it's also not good to say it's significantly better for one group and another and not have any incentive to change it. So what role does policy have to play? And I think the role science has to play is pretty clear to me, figure out how to make these data sets more representative, but actually doing that, the incentives don't feel like they're in place right now for anyone to do that, except to just because we feel like we should and must. But at the end of the day, it's not being required by the FDA, for example.
Yeah. So I think, what we've been seeing recently, in fact, it's not recent. There's a very, very long history of this, but we're seeing a sort of renewed push around diversity in genomic studies. I think these are like not quite so straightforward calls as they at first seem. So diversity of what, right? So people talk about ancestry and or genetic ancestry, and as if everybody knows what everybody else means. And this is emphatically not the case. If you try asking a geneticist to define ancestry, they're probably going to stumble over their words. If you ask a physician how to find ancestry, you're going to also get a similar stumbling, but arriving somewhere different. Likewise for somebody in public health. Certainly likewise for somebody in the social sciences who tend to see ancestry as part of our identity, about the stories we tell about ourselves and how we're linked to our forebears. So it's a very, very slippy concept. But even if we focus in on, somehow it's something to do with our genetics and something to do with how that's come down through the generations, then there's no clear definition. But B, the sort of definition that's being inserted is continental ancestry. So European ancestry, African ancestry, Asian ancestry. And these massive categories end up looking very much like the races, biological races of old. And that's just like the critique of that is what we continue to see with people being like huge debate in the sort of clinical algorithms literature and in practice about how race should be incorporated into, for example, a score for kidney function, or for whether you've suffered from concussion, or a lot of these daily used scores in clinical medicine factor in race. And we're having a moment of reckoning around that. And in general, the social scientists have been pointing out to us for a long time that, biological race is hugely problematic in all sorts of ways. You can use it only as a proxy for racism, basically.
Right.
So all sorts of problems with biological race. But then some people are like, oh, okay, but there's something to do with genetics, and that's okay. And, I fear, and others join me in this fear, that the use of these continental ancestry categories, we kind of bring biological race back in through the back door. And of course, what we know is that we are not these like well-defined groupings. We're spread out with some structure, but we are spread out through genetic similarity space. And anything where we carve that space up is problematic. So I think there are some valid uses of these continental ancestry categories, but I also think that they're massively overused. And it's in genetics, if what we end up meaning by diversity is these continental ancestry categories, we're putting a lot of emphasis on genetic differences between individuals. And we've removed entirely other differences. So there's a much, much, much smaller literature which points out that these polygenic risk scores, they actually vary in predictive power if you look across socioeconomic class or if you look across gender. So I think we risk focusing on genetic diversity. We risk losing out on all these other things, which actually are probably more important for health disparities. So I see a real danger there. In terms of work that is being done, I do think that funding agencies are putting money where their mouth is when it comes to recruiting samples, but I have my reservations about the way that is being done.
Here's a wild card discussion. So here in the UK, there's plans to sequence 5 million people through a new project called Our Future Health. It's probably conceivable that in the UK or in the US, they'll sequence everyone. I'd say by 2040, I'd be really surprised if we haven't sequenced everyone. Mm-hmm. In some sense, we'll then have solved this problem we've just been discussing, because at least in a given country, everyone will be sequenced. But it doesn't solve the underlying problem, which is if there are fewer people of a particular group, whatever defined as, then the scores are going to underperform in those groups, I'd assume, relative to the larger group. So I wonder whether there is a solution in sight for this, and how we ultimately handle this. Even if we've sequenced everyone in the US, then individuals of a particular genetic and ancestry group, you've now rocked my worldview of what ancestry actually even is. So I'm struggling to place words for it. But yeah, what do you think about these population scale programs, and does that change things?
Well, you put your finger on many interesting things there. And one thing I like that you're using representativeness language rather than diversity language, because diversity is very, very ill-defined. Something you can seek to do is to be representative of a particular population, for example, the population of a country. So you can seek to do that. And another thing I wanted to mention is it's not just raw numbers of individuals that count. So at least as long as it's genotype data that we have for all these individuals, these differences in predictive power capture all sorts of things. But one of the things that they do capture, which is kind of unambiguously associated with genetics, are patterns of linkage disequilibrium, which is a feature of population history. So I know many geneticists who believe that even if we get truly, truly massive samples of, like, say we do lots of recruitment in Africa, they're still not going to perform as well, those scores, just because that is where genetic diversity,
more genetic variation to contend with.
Variation. So there are those various things. Another thing that you mentioned that I liked is kind of like, how do we know when we've got equity around, for example, the performance of these scores? Is even the performance of the scores the right sort of level to look at if we're getting to equity? And I think a lot of people in bioethics would be like, well, there are justice considerations here. Equity is important, but we need to be much more precise than that. And being more precise then has implications for what studies should be funded, etc. I think bioethics has stuff to learn here from the sort of machine ethics literature, which has really shown that there are multiple mathematical definitions of fairness when it comes to the performance of predictive algorithms. And think them through and select the appropriate one.
Right. Now that absolutely makes sense.
Yeah. And the other thing you mentioned was, UK by 2040 might have everybody sequenced, and what world would that look like? This is where the sort of contextual pieces are so important around genomics, right? Because the thought of everybody being sequenced in the UK versus the US, for example, where I'm currently based, that's just two very different worlds, right? So in the UK, you can somewhat imagine some direct links into the NHS. You've got the kind of cradle to grave mentality. The NHS has your back. They're hopefully not going to integrate genetic insights until they're able to do stuff with it. If it turns out to be the case that genetic education is really a clear need for a particular sort of genetic education is realized, then it can be added to Key Stage 2 and it rolls out across the country, right? Like the UK is sort of in some ways optimally set up for this type of thing. The key question of trust is a big one. Like, you'd have to trust the government. And there are still lots of open questions. There was a big report that came out earlier this month on sequencing babies, where they did a lot of stakeholder analysis in the UK and ended up with a fairly rosy picture, I have to say, particularly compared to previous scholarship on this question.
Interesting.
That's the UK. In the US, almost none of the things that I just mentioned are in place. And it's just a completely different ball game. And then many other countries are going to have similarly different contexts in which you can imagine this technology being inserted. Yeah, like imagine the Chinese government having sequence data on everybody, or it's going to be very variable. And I think that a lot of the bioethics work we do, we assume that our norms and principles are then just going to roll out and live with the technology. Like, the technology is definitely going to spread, I don't doubt that. But the norms and principles which we sort of assume are packaged with it are not going to be as sticky as they cross national borders, I don't think.
Yeah, fascinating. I feel like I could talk about this for another hour, but I think we both probably have other Zoom meetings we need to attend. So I wanted to, and respect your time, but I'd love to just close out with one more question about what you're working on now that maybe we've touched on or haven't discussed, because we talked about a lot of your past work. In particular, we didn't touch too much on some of the discussion that's going around with polygenic scores and selection on an embryo level. Maybe we can revisit that at another time, but I'd love to hear about what's on the horizon for you, what you're working on and most excited about.
Well, I say I'm thinking about two things, or more specifically writing two grants. One is around sequencing babies. And I think the context of new genetic therapies really changes the landscape, because in order for many of those genetic therapies to have an optimal effect, you need to know who would benefit from them as soon as possible. And that means sequencing babies. And we know people have all sorts of hesitations around that. So what does putting best foot forward look like for sequencing babies? And the other one, and I mentioned this before, is genomics is the original ELSI, ethical, legal, social implications field. But I think that there are other fields. So generation of biological data for machine learning is an obvious one, where what we need to do is sort of learn from the successes and failures of the ELSI genomics world and create these new ELSI fields for these other technologies. So I'm also excited about that.
Excellent. If people want to follow you and keep up with your work, I know you're on Twitter, and they can visit you on the Harvard website if they just type in Anna C. Lewis.
acflewis.com is my website, and I'm not a very good tweeter. I think I've tweeted once in the last couple of years. So that's not a good
Great. So go to acflewis.com. I checked out your website before the call, and I know you said that you've stopped writing as much during the pandemic, but there's a huge amount of really interesting, it seems like for a long period of time, you were basically pulling all the most interesting things that were happening in a given month in genomics and basically just doing a rundown. So it was a little bit of a trip down memory lane. I got to read about the He Jiankui gene editing issues and all sorts of things that were kicking off 1 or 2 years ago. So definitely worth checking out their website.
Well, thank you. Well, this was a lot of fun. Thank you, Patrick, for having me on.
It was. Thanks so much for taking the time, and hope we can do this again soon. Maybe we can do a deep dive into baby sequencing. I need to read the outputs of the work that was done here in the UK. I haven't had a chance to check up on it yet, but I'm interested in hearing what you're working on and learning a little bit more about that. Thanks so much.